Hello everyone. In this video, I'm going to explain fundamentals of color image processing. So as all of us know that there are three basic colors, you can say, or you can call it as a primary colors, that are red, green and blue. When we mix these primary colors, we get secondary colors, that is cyan, yellow and magenta. That means when we mix red and green, we get yellow. When we mix red and blue, we get magenta. And when we mix green and blue, we get cyan. Similarly, these are secondary colors, and when we mix secondary colors, we get primary colors. That is, when we mix cyan and magenta, we get blue, and so on. Now, there are three characteristics of color. Let's start with the brightness. What is the meaning of brightness? Many a times we adjust this brightness in the images on mobile phone by using different applications. Now, what is exact meaning of brightness is? Brightness means amount of intensity. Brightness is an attribute of visual perception in which source appears to be reflecting light. You can see here an example of a water source or water on which light is falling, and then light will be reflected by the surface of water. So on the surface of water, the reflection of light is more, and hence brightness will be more. And when we go deeper into the water, the reflection of light will be less, and that's why there you will say you can see less brightness. That means this intensity of color, or you can say amount of intensity or brightness, depends on how much light is getting reflected. More is the reflection, more is the brightness. Now, next characteristic is hue. What is hue? Hue represents dominant color family of a specific color we are looking at. So what is hue? Hue is the dominant color of a particular color family. You can see here the color on the outermost perimeter of the color circle are hues. You can see here this is a color circle. You can see here outermost perimeter. So if you see, concentrate on this. If you say this is a red color family, wherein red is dominant on the outer circle, or you can see here this is a family of orange color. So outermost color shows the dominance, or yellow color or green color family. So outermost you can see a dominance of particular color or dominance of that particular color family, and that is known as hue. So colors on the outermost perimeter, that means all the colors on the outermost perimeter of this color circle are hues, which are colors in their purest form. So these are purest form of colors. Now, next characteristic is saturation. What is saturation? Saturation refers to intensity of color in image. Means how much is the intensity, or you can say how much is the level of color in that particular image. As saturation increases, you can see here an example. As saturation increases, the color appears to be more pure form. So more is the saturation, you will get that color in the more pure form. This is a pure form of red color. As the saturation decreases, you can see here saturation is decreasing in this direction, and here you will get pale colors or washed out color of the same family. So these are the three characteristics of color, that is brightness, hue and saturation. Now there are different color models. Here in this video we are concentrating on three main or important color models. The first is RGB color model. RGB stands for red, green and blue, and these are used in monitors of video cameras, color monitors and video cameras. Then second color model is CMY, stands for cyan, then magenta and yellow. This color model is used for color printing. And next is HSI, that is hue, saturation and intensity color model. This color model is used in various applications of image processing. So color models, what color models does? Color models provides a standard way to specify a particular color by defining a 3D coordinate system. So these colors are represented in the form of 3D coordinate system, let's see one by one. So let's start with the RGB model. So what is the RGB model? RGB, as name suggests, it stands for red, green, and blue model. An image consists of three independent image planes. So there are three independent image planes. You can concentrate here. This is red. Here it is green, and here it is blue. If you see in this image, this is red, this is green, and this is blue plane. What happens? Figure shows the geometry of RGB color model for specifying colors using Cartesian coordinate system. Now you can see here, it is this red plane is represented by 1, 0, 0. So what this 1 represents? 1 represents the presence of red color. And this represents absence of green color, and 0 represents absence of blue color in this direction. If you see this blue plane here, it is 0. 0, this first 0 indicates absence of red color, this indicates absence of green color, and this represents presence of blue color in this direction. So blue is present in this direction. You can see here blue is present in this direction. Similarly, it goes for green. If you see this is green plane here, it indicates presence of green color, absence of blue color, and absence of red color. And that's why R is 0, G is 1, and blue is 0. So this is how we can represent colors into this Cartesian coordinate system. Now you can concentrate here. Let me take color change. Yeah. Now if you see here, you can see this is a green plane, this is red plane, and this is blue plane. When we mix blue and green, you get, so when we mix red, when we mix blue and green, what do we get? We get cyan. So here you can see this cyan color. Similarly, if you see in this direction, the red color is getting mixed with green color. So when green color gets mixed with red color, we get yellow, and hence in this coordinate system you can observe here there is yellow color. But in this direction there is absence. When this is a blue, particularly blue plane, on the blue plane the red and green are absent. In green plane the red and blue are absent. In the red plane the blue and green are absent. The grayscale spectrum, those color made from equal amounts of each primary, lies on the line joining the black and white vertices. So here you can see there is a white vertex, and here there is a black vertex, and this line indicates gray color. Where do we use the RGB model? The RGB model is used for color monitors and video cameras. Now the RGB model. We represent each RGB from 0 to 25. That means each shade, I can say each shade of R can be represented from 0 to 255. Each shade of green can be represented from 0 to 255, and blue can be again represented by 0 to 255. If you observe here, you can see that darkest means lesser value. Smaller is the value, it goes towards black or darkest shade of that particular color. And when it goes towards 255, it is the more brightest or pure form of that particular color. Similarly, you can see here 78, which is more close to 0, and hence it is the darkest shade of blue. In fact, if you see here, this 246 is like highest value. So it is close to or it is a brightest shade of red. So each RGB color image means every color image consists of 3 component images. That means every color image is addition of these 3 images, 1, 2, and 3. That means each color image is addition of a red plane, green plane, and blue plane. And when we add these 3, we get a color image. Now, the intensity of every color is represented by a number from 0 to 255, and hence each can be represented by 8 bits. So if I want to represent 122, I need 8 bits to represent this 122 in the form of sequence of zeros and ones. So 0 can be represented by 000000000, and 255 can be represented by 11111111, and all other shades of these particular colors can be represented by that bit patterns from that are a sequence of zeros and ones. Now here you can see the example. Here red is 255, the green is absent, and blue is also absent, and hence it is in the form of pure red color. Here you can see that red is 255, the green intensity is 128, and blue is absent, and hence it is like orange color. Here it is 191, green is 255, and blue is absent, so it is yellow color, and so on. And hexadecimal, it is also represented by hexadecimal numbers. Now, as I said, every image, every color image is addition of 3 components of RGB. So you can see here, this is a red component, this is green component, and this is blue component. When we add these 3 images, we get this particular color image. You can see I have shown here the example. What is written? The total number of bits used to represent each color pixel in RGB image is called as pixel depth. What is the meaning of this? As I said, each color image consists of addition of red, green, and blue plane. So here I have shown this is blue plane example, green plane, and red plane. There are different color shades varying from 0 to 255. Here if you take this particular pixel, this particular pixel, and this particular pixel, and if you see this corner pixel is addition of, or it is represented as pixel 68R, G is 255, and blue value of blue pixel is 150. That means each pixel of color image has a depth of 24 bits, because to represent 68 I need 8 bits. To represent 255 of green, we need 8 bits, and to represent 150 of blue, we need 8 bits. And in color image, it is 68, 255, because it is addition of all these 3. And hence, to represent a color image pixel, we need 24 bits, and hence it is said that the depth of RGB image is 24 bits. And so on. The second pixel will be addition of this, this, and this. The third will be addition of this, this, and this, and then so on. So these are different planes of images. If you open a Microsoft PowerPoint, and if you adjust any of the color that you want to use, either for the text or as a background, you will see it opens this text box. And when you adjust this arrow, it will change the value of RGB. So what is this value of RGB? It is nothing but these values of RG and B. Whenever you want to select a particular shade of, say, red or green or blue, it will change the intensity, or you can say the level of red, green, and blue. So remember, every color image is addition of 3 image components, that is red component, blue component, and green component. Now next model is CMY model, that is cyan, magenta, and yellow model. This is subtractive model. What is meaning of subtractive model? RGB model asks what is added to black to get particular color. When we use RGB as a basic color, as a primary color, then RGB model asks what should be added in the black to get particular color. Similarly, if we use CMY model, it will ask what should be subtracted from white to get particular color. In this case, cyan, magenta, and yellow are primary color, and red, green, and blue are secondary colors. So in RGB model, red, green, and blue are primary, and cyan, magenta, and yellow are secondary colors. And in CMY model, C, M, and Y are primary colors, and red, green, and blue are secondary colors. So as I have shown you earlier also, when we add magenta and cyan, we get blue. When we add magenta and yellow, we get red. And when we add cyan and yellow, we get green. Now, how to convert one RGB model into CMY model or CMY model into RGB model? That means how to convert one color model into another color model. So formulas are given. If you want to convert CMY into RGB, you have to subtract each value of CMY from 1. And if you want to convert RGB into CMY, you have to subtract RGB from 1. Now the question is how to convert these values from 1. As I said, the RGB values varies from 0 to 255. So for doing this, we have to normalize these colors. How do we normalize? We subtract the RGB value by 255. We normalize it and then we subtract it from 1. So I will show you one of the examples. So what is the example? How to convert RGB into CMY. So for example, it is given RGB values of 35, 98 and 156. What is meaning? This is red, this is green and this is blue value. And we have to convert it into CMY. So first, before starting, we have to normalize this. How to normalize this? So I will calculate R dash, that is 35 divided by 255, will get this. Then G dash, that is 98 divided by 255, will get this. And blue, that is 156 divided by 255, will get 611. After normalization, then we have to use the same formula that I have shown earlier. If you want cyan, then 1 minus R, that is 0.137. So you will get value of cyan. Then magenta color value. So 1 minus green, that is 1 minus 0.384. So you will get this. And yellow, for getting yellow, you have to subtract 0.611 from 1. So you will get 0.389. So this is how you can convert RGB to CMY. Now next color model is HSI color model. What is HSI color model? HSI color model represents every color with 3 components, that is hue, saturation and intensity. Now here this coordinate system for HSI model is shown. You can see here the saturation is varying in this direction. This end represents black, this upper end represents white. Intensity is increasing in this direction. That means here the intensity is lowest and at the top intensity is highest. Colors, you can say at this end there is a red color, then yellow, green, cyan, blue and magenta. So there are rings of colors. If you want to have a detailed look, you can see here this cone is represented here. This cone, whatever is shown here, this particular cone is represented in this diagram. You can see the saturation is increasing in this direction. The saturation varies from 0 to 1. As I have told earlier also, highest value of saturation gives you the original color or original level or original color of that particular color. That means if saturation increases, you will get the original form of that color. And when saturation decreases, you will get a pale form or dull form of that particular color. The hue component describes the color in the form of angle between 0 to 360 degree. So if you see hue, as I told you, hue represents the outer ring. Outer ring means again it is the purest form of that particular color family. So again hue will change as an angle. So angle here hue is 0 degree and in this direction it will rotate like this and here again it will comes to 360 degrees. So the hue component describes the color in the form of angle that varies from 0 to 360. The saturation component describes how much color is diluted with white light. As I shown you, in this direction the saturation is diluted. In this direction here it is in the purest form. So saturation here it is the color is in its purest form. The range of saturation varies between 0 to 1. 0 means it is impure form, 1 means it is pure form. The intensity you can see, I have shown you intensity varying in this direction. That means on the downside it is black, the intensity is minimum, and on the upper side it is highest. The intensity ranges again between 0 and 1. 0 means black and 1 means white. So this represents HSI color model. Now, what are the formula for converting colors from RGB to HSI? Suppose I have RGB colors and I want to convert it into HSI model. So there are formulas. The UH is given by H is equals to theta if blue is less or equal to green. And if blue is greater than green, then you have to use this value 360 minus theta. Where for theta the formula is given, we have to use this formula. Then the saturation S, for saturation again the formula is given, S is equals to 1 minus 3 upon R plus G plus blue, and minimum of R comma G comma Y, means whatever is the smallest that you have to multiply with this formula. And intensity I is given by R plus G plus B divided by 3. Here again you can see the HSI model with clarity. Here as I shown you, here it is black, here it is white. The U is, this is the angle of U in this direction. It starts with 0. That means it starts with red and then ends with again red. The intensity you can see here, intensity is equals to 0.5. Here intensity is increased, that is 0.75. So intensity is increasing in this direction. Now let's solve an example. Convert RGB, so 29104 and 215 values to HSI. So before starting, what we will do, first we will normalize these values by dividing by 255. So we have divided by 255 and we have got these values of new values of R, G and B. Now the intensity I is given by I is equals to 1 by R plus G plus B. Very simple. So what we have to do, we'll add these three values and divide it by 3. So we'll get value of intensity. Very simple formula. Next, the saturation. Saturation is given by 1 minus 3 by R plus G plus B and minimum of R, G and B. Which one is minimum in R, G and B? So R is minimum. So we'll take minimum. So I have represented this R, G and B value. So we have to take minimum of this. So what is minimum? Minimum is 0.113. That is R value is minimum. So let's solve this formula. After solving, we'll get this value of saturation. And now we have to solve for U. For U, we have this condition. So first we have to check whether blue is less than green or not. So in our example, blue is greater than, you can see blue is greater than G. So we have to use this particular formula, 360 minus theta, because blue is greater than green. So first we'll calculate theta. So for theta calculation, there is a formula. So let's calculate by taking theta is equals to cos inverse of, and then put all the values, solve this equation. After solving, subtract it from 360. So here I have not done it, the final solution. So solve this formula, you will get some value. And then for calculating H, what you have to do? You have to take 360 and then subtract this value, whatever you get here, and you will get value of H. So I hope you understood the fundamentals of color image processing. Still, if you have any doubt, you can always ask in the comment section. Thank you. Thank you very much.